One of the big topics being discussed in Vue 3 is around TypeScript. However, for those of us who haven't jumped on the TypeScript train yet, there's understandably a lot of hesitancy when it comes to adding TypeScript to our codebase. In this lesson, I'll be addressing some of these concerns in order to provide another perspective to help evaluate whether or not TypeScript and Vue is a good combination for your project or not. Let's get started. Let's take a minute to level set as far as what TypeScript is. Here on the official TypeScript website, we can see that they define TypeScript as an open source language which builds on JavaScript, one of the world's most used tools, by adding static type definitions. Some of you might be looking at this definition and thinking, static type definitions. Well, if you haven't worked with static types before, let's take a look at a normal JavaScript variable called mystery box. JavaScript, by default, is what is typically called a dynamically typed language, which means that the variables can be assigned any type of value. That means our mystery box label could contain a string, number, boolean, array, object, or something else entirely. While there are a lot of benefits to this, one of the downsides is that it can be difficult to predict how something should or should not behave. So, in the event we had a variable called myAge, we know as the author of this code that it should be a number. However, in the event that someone else had to implement a function called increaseAge, without any other tooling, the only way for them to check whether or not myAge is the correct data type is to add a conditional statement to address whether or not myAge is the correct type of number. This is where static types can have a lot of value. With that said, what is the cost of using TypeScript? Like any dependency you add to your codebase, the biggest cost is typically the learning curve and effort required for new developers to become productive with the new tool. As more and more developers come into the world of programming with JavaScript as their first language, this means that with TypeScript, there are a lot of new paradigms and things to learn, which can be very expensive to teams with tight deadlines. And let's be honest, using TypeScript in a codebase seems like it is a little more than just simply adding a library to handle a specific function of the application. After all, when we hear most people talk about TypeScript, their entire application is often written in it, and it's probably hard to imagine spending time rewriting your codebase when most of us don't even have the time to factor the technical debt that already exists. And of course, even when people have added TypeScript to their codebases, that doesn't suddenly mean that their code is bug-free and perfect. After all, like with any tool or technique, they all have their compromises and trade-offs that often require experience and lessons learned to fine-tune so that it fits the team properly. Having heard all this, of course, the real question here is it worth it? The first concern that many often have with TypeScript is that it feels different and strange. However, for those of us who have used Vue for a little bit, the truth is that chances are very high that you've been working with static types this entire time. Don't believe me? Let's dive into a component. Here, we have the proverbial button component, which receives two different props: the color to set the background color of the button, as well as the text, as far as what's displayed inside of the text. While many of us started defining props in this array syntax, as we see here, most of us eventually converted to using the object syntax to better define our props. As we can see here, the color is a type string with default blue, and the text prop is a type string and is required. And for those of us who knew about custom validators, we often went one step further to add custom validators to ensure that the component received the correct data. In the case of the color, we wanted to ensure that it was only passed either red, green, or blue, and that checks to ensure that the prop receives the correct data. After looking over this new and improved version of props on our button component, what you might have realized by now is what we've actually done is assign a static type to our props. In other words, whether you realize it or not, you've been leveraging static types this entire time. Of course, now that we've demystified the use of static types, the real question here that still remains is TypeScript worth it? And while TypeScript has a lot of benefits when it comes to features like type checking, at the end of the day, we have to remember that all tools and libraries have some sort of trade-off and compromise. As a result, Whenever I'm thinking about adding a new tool to the codebase, I want to make sure that it solves a specific problem that we're actually having rather than trying to optimize in advance. In my opinion, when a team has little to no experience with TypeScript, the value that TypeScript can bring to a codebase ultimately boils down to one factor: scalability. And scalability can be broken down into roughly two categories. One, how large your codebase is, and two, how many contributors your codebase has. When we look at Angular, which is a highly opinionated framework that was designed primarily with enterprise companies in mind, their decision to make TypeScript mandatory is something worth considering. As a codebase grows in size, this often means that there are greater complexity as far as moving pieces that ultimately make the application work. Because of this, TypeScript's ability to provide data structures that the team can rely on can be critical to their productivity. As a result, this is why we see a lot of companies investing in TypeScript for their code bases, because it also provides that additional layer of documentation that might otherwise be lost if the original author of the code leaves and unfortunately happen to forget to comment their code. On the other hand, there are those who are probably thinking, well, my application is small, so how would TypeScript benefit me? For people in this scenario, TypeScript is particularly beneficial typically if your application has a large number of contributors. The most common scenario for this is those who maintain open source projects. After all, since people can be contributing to an open source project at basically any given time, this means that the ability to provide structure and consistency to contributors is critical. After all, in addition to ensuring that the codebase works as expected, it also has the added benefit of reducing the amount of time that maintainers have to spend answering questions or resolving PRs that might otherwise have been solved if static types have been properly defined inside of the codebase. So what about TypeScript support in Vue? One of the biggest hurdles that people often encountered when using TypeScript in Vue 2 was that while it was technically possible, there was a rather high cost of entry and some things didn't work as well as some people might have liked. For example, being able to detect types across your Vuex stores wasn't exactly easy, and people often had to make compromises when it came to this. When hearing this, it's no surprise that many chose to avoid adding TypeScript to their Vue 2 projects. For those who don't know though, Vue 3 has been rewritten entirely in TypeScript, which means that developers can expect much better TypeScript support going forward. So whether it's developer tooling such as Viter or libraries such as Router or Vuex, using TypeScript will become a lot easier. And as a result, the cost of entry is now lower than ever before. This brings us to my next point, which is that TypeScript can be added incrementally. A misconception that many often have is that using TypeScript is all or nothing. After all, if you're going to use TypeScript, shouldn't your entire application be rewritten in it? The reality is that this couldn't be further from the truth. So rather than feel pressured to rewrite your entire app in TypeScript, I recommend choosing a specific feature where you will enhance it with TypeScript to see whether it's worth it for your team or not. And if you and your team are seeing the benefits of TypeScript, then keep on refactoring and adding it until one day, you might just realize that your entire app is now in TypeScript. Let's review. In this lesson, we've talked about what TypeScript is and how it relates to the JavaScript that we're used to writing. We've also talked about some of the pros and cons when it comes to using TypeScript and why it might or might not be good for your project. And finally, we also covered how TypeScript support is in the Vue ecosystem, especially with Vue 3 being released. At the end of the day, the important thing to remember here is that TypeScript might not be a good fit for your project or your team. And if that's the case, that's perfectly fine. However, if it feels like TypeScript might have some value in your current or future project, then be sure to stick around as we go into the fundamentals of using TypeScript with Vue 3. See you in the next lesson. And while many of us started by Welcome to lesson 2 of Vue 3 and TypeScript. Today, we'll be talking about how to set up TypeScript with a brand new Vue project and how to add TypeScript to an existing Vue 3 project. Let's start by talking about the prerequisites for getting set up. If you've taken some of our other courses such as Real World Vue, the CLI should be familiar to you. If not though, here's the Vue CLI docs where we can go ahead and click on the Get Started button in order to learn more about Vue CLI. On the left, you'll see an installation link, which we'll go ahead and click. And here you'll see inside of the code block the commands we need to run in order to install Vue CLI on our machine. Switching over to our terminal, to start, let's check our node version. I'm currently on version 12.19.0, which is the latest stable version. Next, we'll go ahead and install Vue CLI by running npm install -g, which stands for global, at vue/CLI. To verify everything's set up correctly, we can run vue-version, and as you can see, I'm currently on 4.5.8. Now that that's taken care of, let's go ahead and set up a brand new Vue 3 project with TypeScript. To do this, we run vue create and we'll call our project Vue 3 and TypeScript. We'll go ahead and manually select our features, where we have choose view version and Babel already selected, and linter, but we'll turn on TypeScript by hovering over it and pressing space. Then we'll choose 3.x for our version, no for class style component syntax. We do want Babel, so that's yes. For linter formatter, I like ESLint and Prettier, and we'll go ahead and leave the default lint features to lint on save, and we'll save them in dedicated config files. And I don't want to save this for future, so I'll say no, and off it goes. After clearing my terminal, let's go ahead and change directory into Vue 3 and TypeScript. And we'll open VS Code to take a look at what's inside. In our application, the first thing you'll probably notice is that main.js is now main.ts. And when we open the file, even though it is a TypeScript file, you'll see that inside is basically equivalent to main.js. Nothing's really changed. Another file that might look a little weird to you is this shims-vue.t.ts. And so what you need to know about this is that this is basically a helper file for TypeScript to give it a better definition of what's going on with the .vue files. In other words, it's just a helper file for TypeScript. No need to modify it. Finally, you might have noticed there's also a tsconfig.json, which contains different configuration options for the TS compiler. It has things such as paths, which contain where it should look up certain things based on things such as the @ symbol, where it'll look into source, and the include option, which tells TypeScript what files to look for that it will help to compile and watch. And if we look closely at the rest of the folder, you'll see that nothing else has changed. Everything else is quite standard as far as Vue apps go. And when we open up our app.vue component, you'll see some of the things in our script blocks have changed, but don't worry, we'll get to that in the next lesson. Now, some of you may be thinking, that's great, but I want to add TypeScript to an existing Vue 3 project. Well, I've got you covered there too. I've gone ahead and created a Vue 3 project in advance, and it's called an existing Vue 3 project. Inside, you can see that everything is standard, nothing has been configured, and we can see its normal script block and our main.js. Everything is just normal JavaScript right now. So let's go ahead and add TypeScript to this project. Back in our terminal, you'll see that I've already changed directories into an existing Vue 3 project. To add TypeScript, we only need to run a single command, and that is vue add TypeScript. This leverages the Vue CLI plugin in order to go ahead and configure everything inside of our application with just one command. For our configuration objects, we still don't want class style syntax, so we'll say no. We do want Babel, so we say yes. We want to let it convert all our JS files to TS, but we don't want to allow any JS files to be compiled. And finally, we do want to skip type checking of all declaration files, which is recommended. Once everything is done, let's jump back over to VS Code to see what's changed. As you can see now, our main.js has now been converted to main.ts, and we have the shims file that we saw from earlier. And finally, we also get our tsconfig, just as you would expect. One thing that's worth noting is that even though it looks like app.vue was converted into a TypeScript component, this is simply a scaffold that TypeScript plugin provides as a way to show you that everything's working. In the event you had an application with more components, that's still something that you'll have to manually migrate over to TypeScript, since it doesn't want to automatically make inferences and break your app. Something to keep in mind. And with that, let's review. In this lesson, we've learned how to set up a Vue CLI project with TypeScript from scratch, and we've learned how to add TypeScript to an existing Vue CLI project. And finally, we've covered what the application looks like when we add TypeScript, and thankfully, it's not a huge departure from standard Vue CLI apps, which is great because that means the learning curve is just that much easier. Thanks for watching, and I'll see you in the next lesson. In the last lesson, we learned how to set up TypeScript with Vue CLI on a Vue 3 project. Now, let's go ahead and see what exactly has changed inside of our .vue files. Here on line 6, you'll notice that we're not just using a plain old script block. In fact, there's a language attribute on it, which is assigned the value ts, which you might have concluded to mean TypeScript, and you'd be correct. This allows us to tell Vue that we're going to be using TypeScript in this block instead of normal JavaScript. Now, on line 7, we have something here that might be a little bit different from what we're used to in Vue 2. What we're doing is importing a Vue helper function that allows us to define components in a way that works well with TypeScript. And we're doing this by importing it from the Vue package. And now, when we take a look at Hello World, you'll see that we have the same lines here where we have the language TypeScript and we're importing it here. And this brings us to our final difference in the components, which is that on line 100, you'll see that the export default no longer just exports an object. And this is where we actually declare our defined component in order to call the fact that we're actually going to be defining the component. And though it might seem really straightforward, believe it or not, that's all it takes to add TypeScript to our single file components. If you haven't had a chance already, be sure to check out Adam's Real World Vue 3 course, where you'll be building this event site that I'm showing right here. You can see that we have different cards for the events. We're able to toggle from the About page to the Events page, and then we can click into the card to see more details about the events on a specific page. And if you want to follow along, be sure to check out the repo at github.com/codepop/realworldvue3 TypeScript. Here inside of our project, we'll see that there's nothing to do in app.vue since there's no script block. However, in the eventless component, let's go ahead and convert it to TypeScript. I'll start by importing an object from Vue, and the reason I do it like this is because this allows us to utilize autocomplete, which makes typing a little bit easier. I can then do the same thing on line 14 by typing out define component, and you'll see it automatically autocompletes. Once that's done, the final touch is to simply add the language attribute with the value of ts. However, you'll notice though that our VS Code now is yelling at us and saying something's wrong. Well, the problem is that right now, at the time of this recording, TypeScript is unable to infer what the @ symbol means. And so, in order to fix that, what we're going to do is we're going to go ahead and define the relative path explicitly and not use an alias to refer to the root path of the source directory. Once we do that, our error goes away and everything looks great. It's important to note though that this is just a temporary fix. In the future, we can expect better TypeScript tooling as the ecosystem matures around Vue 3. Now, with that said and done, here's your challenge for this lesson. Go ahead and convert the event-details.vue component into TypeScript, and then we'll also want to convert the event-card.vue to TypeScript, which is located in the components folder. You can find the starting code for this challenge in Lesson 3 Challenge. And with that, let's go ahead and review what we've learned this lesson. And even though it only took a few steps to add TypeScript to our single file components, it's important to understand that we've now learned how to configure TypeScript inside of single file components and utilize helper methods to ensure that our components work well with TypeScript. Thanks for watching, and see you in the next lesson. One of TypeScript's fundamental concepts is the ability to define static types in order to enhance development. In this lesson, we'll be taking a look at foundational concepts that you should be aware of as you start your TypeScript journey. As a quick review, common JavaScript types that we often encounter include string, number, boolean, array, function, and object. These form the foundation of most applications built with JavaScript. But in the world of programming, there are many other data structures worth knowing about. To learn more about other types and data structures that exist in JavaScript, be sure to check out the MDN documentation that we'll go ahead and link in the article below. And while JavaScript comes with a lot of native types, TypeScript also offers additional types commonly found in other programming languages, such as the any type, which essentially disables any type checking, the tuple type, which is basically a fixed length array with predefined data types. In this example we have here, we want to define the RGB colors in an array, but RGB only consists of 3 numbers, and tuples are a great representation of this data structure, since we don't want any more than 3 and we don't want any less than 3. There's also the enum type, which allows you to define friendly names to a set of values. In this example here, we have an enum called arrow keys, which has 4 values: up, down, left, and right. And while this might not look really special, what's happening under the hood is that enums by default will start from a value of 1 and then increment by 1 each value going forward, which allows you to set those human-friendly names, which can then be assigned to a set of numbers like we see here. This is just a small sample of what TypeScript has to offer in terms of predefined types. To learn more about everything that TypeScript has to offer, be sure to check out their official docs, which we'll link in the article below. Now that we've gone over types, let's go ahead and learn how to define a type on a variable. Let's start with string, numbers, and booleans. In order to add a type with TypeScript, this is done by appending a colon along with the type that you want the variable to be assigned to. As we can see with stage name, we've gone ahead and assigned it a type of string. As you can see here, the colon is the key to this syntax. For numbers and booleans, it's done the same exact way by adding the colon along with the type following it. One of the things I want to emphasize here is you'll notice that all of the types are lowercase. This is the convention set by TypeScript and is one you should follow as well. Now that we've covered strings, numbers, and booleans, the question is, what about arrays? Well, at first glance, you might be tempted to just follow the syntax that we learned earlier, by simply adding a colon and then the type array in lowercase. However, unfortunately, this is wrong. When it comes to arrays, there's a special syntax that TypeScript used to define it. After all, while an array is a data type, the question is, what type should exist in the array? This is how specific we need to think about things when using TypeScript. In the case of our shopping list example, you'll notice that our array consists of only strings. Since we want an array of strings, what we do instead is we actually define the type of data that will be inside of the array first, in this case string, and then we append it with the square brackets indicating that it should be an array of this data type, which in this case is an array of strings. Now, what about functions? When it comes to adding types to functions, there are 2 key parts to keep in mind. 1, your parameters, and 2, what you'll be returning from the function. Here, we have a function called generateFullName, which takes 2 parameters, the first name and last name, and we're going to go ahead and return a string at the end of it that combines the 2. However, as you might have guessed, this leaves us vulnerable to having random data types being passed into our function when we really only want strings to be passed in. So as the first step, we want to define the types that are expected on our parameters, which in this case are strings. And we do this using the same syntax we saw earlier, where we append the variable name with a colon along with the data type that we want it to be. However, we're not done yet. The one last thing we need to do is define what type of data we expect to get from the function, which we do by using the colon after the parentheses that define our parameters. And then we define the type that's expected, which in this case is a string. And those are the basics of adding types to our functions. In TypeScript, objects are where things begin to get a little more interesting. But before we can get into those pieces, let's start with the fundamentals of how to define types on object values. In the case of our person variable, we have an object here with 4 key value pairs. We have the name, with Peter Parker as a string, age, with the number of 20, whether or not he's an active Avenger, which in this case is true, which is a Boolean, and finally, we have his powers, which is going to be an array of strings. If we wanted to define the types that are expected for each key value pair in this person object, we would start by adding the colon, but then we would actually use curly braces to define our object definition. While you might have thought that we could use something like object similar to how we did numbers and booleans, objects are unfortunately more like arrays where we need to be more descriptive about what's inside of it and not simply point to a generic data type. As a result, inside of this object, we can now define each key value pair just like you would in the examples we saw before. Our name is a string, our age is a number, and our active Avenger is Boolean, and the powers is an array of strings. At first glance, this might look really odd. After all, it looks like you're defining the object twice. In addition, you might have also noticed that the type is not a traditional object because there are semicolons instead of commas. However, this is a convention set forth by TypeScript, so it'll just have to take a little getting used to. And while a lot of incredible things have and continue to be built with predefined types provided to us by JavaScript and TypeScript, the reality is that there leaves something left to be desired when it comes to providing more descriptive types. What if we wanted to define a One of TypeScript's fundamental concepts is the ability to define descriptive types. What if we wanted to define a custom type that only allowed developers to use a predefined set of button styles? For example, we have a primary, secondary, success, or danger button, and we only want the button styles variable to contain one of those 4 values. However, with the knowledge that we currently have, we're unable to define anything further than the type that's expected inside of button styles, which is string, which means it doesn't do much for us as far what if we wanted to define a custom type that only allowed developers to use a predefined set of button styles? For example, we have a primary, secondary, success, or danger button, and we only want the button styles variable to contain one of those 4 values. However, with the knowledge that we currently have, we're unable to define anything further than the type that's expected inside of button styles, which is string, which means it doesn't do much for us as far as protecting developers from assigning the wrong string value to it when we only want one of those 4 values. This is where we'll need to take our knowledge to the next level with defining custom types in the next lesson. In this lesson, we've covered some of the most common types that developers will encounter when building their apps. We've also talked about how to define these types on variables using TypeScript, and we've also discussed some of the limitations that come with only using these predefined types. In the next lesson, we'll be covering one of the key features that makes TypeScript really valuable for developers, and that is how to define custom types. See you in the next lesson. In this lesson, we'll be taking a look at some of these foundational concepts.
There is an element of fun. You find the fun and snap. The job's a game.
In this lesson, we've learned how to go.
Piece of cake, a lark, a spree.
In this lesson, we've learned
that a spoonful of sugar helps the medicine go
in this
down.
lesson.
The
In this
medicine
lesson.
go
As we saw in the last lesson, predefined types can be useful for a number of common scenarios. However, as our applications grow in size and complexity, the need for custom types is a common one. Just as we saw in the example from the last lesson, when we want to confine button styles to just these set values of primary, secondary, success, and danger, string just doesn't cut it, because after all, it can accept any value. And when you want to define custom types, there are 2 methods that account for most scenarios early on: type and interface. In its simplest form, type allows you to define an alias that refers to how the data should be shaped. For example, in the last lesson, we were faced with a problem where we wanted to confine our button styles to certain CSS classes based on a design system. Given our knowledge at this point, the best we could do was limit it to a string. However, through the use of type, we can accomplish our goal. Similar to declaring a variable, you can use type as a declaration of the type of variable. So in this case, we have type button type. And so here in the starting example, we've declared that type button type can only accept a value of primary. And so now, if we swap out our button styles for type button type, this will be perfectly valid because after all, button styles is equal to primary. However, what if we wanted to actually switch it to something like secondary? Well, in this case, this will be wrong because after all, we've told button type that it should only accept a value of primary. So the question is, how do we define multiple types on button type? The answer is the union operator. In the event that you need to allow a type to contain multiple values, this is where the union operator comes in. Before I show you what it is, let's do a quick review of how we would do this normally in JavaScript. We would probably do something like if button type equals primary, or if button type equals secondary, then everything's good to go. And so the way I want you to think about the union operator is that it acts just like the OR operator in normal JavaScript. It just looks a little different. Back in our example, the way we use the union operator is that it's identified with just a single pipe rather than the double one. And thus we have the union operator, which is the single pipe right here. Now that we've applied this, we can go ahead and switch out our button styles for any of the valid values that we've defined, and it would be perfectly valid. So if other developers try to apply this type, such as error button styles, TypeScript will report an error because error does not exist within button type. However, danger button would be perfectly valid because danger is included inside of the button type definition. Equipped with this new knowledge, our button styles now works exactly as we intend it to. So now it's time to move on to interfaces. When getting started with interface, the way I like to think about it is that it's essentially type, but for objects. And so, to show this in action, let's take a look at the object we defined last lesson. As a reminder, we're here with the person object that contains the name, age, whether or not they're an active Avenger, and their powers here. And we have the type prepended at the beginning with name string, age number, active Avenger Boolean, and the powers as an array of strings. However, while the data at this moment isn't too complicated, it's fairly verbose and adds clutter to our code. And it's not reusable if you want to share this with other variables. Wouldn't it be nice if it could look like something like this instead? Where the person is a type of hero that contains all that definition already, and then that can then be reused across other variables. At the moment, this doesn't work because we haven't defined the type hero. But with an interface, we'll totally be able to do this. Just like type, you can declare an interface by prefixing the variable name with interface. So using our hero example from above, it would start out like this, where we have interface hero with the object. With this structure in place, we can now move all of our definitions inside of hero. And just like that, our person is now properly typed and works exactly as we expect. However, a question you might have is, can we combine types with interfaces? And the answer is yes. Let's say we want to enhance our hero interface by defining what comic book universe they live in. Well, without the use of type, it might look like this instead. And so we don't want just a normal string because otherwise the user can put in everything. And let's say we wanted to just restrict it to Marvel and the DC universe. We can do that by declaring a type of comic universe equals Marvel or DC. And now we can add a new property to hero where we define universe as type comic universe. And that way, when we add it to our person, everything will work just as we intend. Let's review. In this lesson, you've learned how to define custom types with the type and interface keywords. And you've also learned how to use the union operator in order to add multiple values to a type. That said, what I want to stress to you is that this is just the tip of the iceberg when it comes to defining custom types, and I've given you just enough to get started. But there's a lot of discussion within the TypeScript community regarding how best to use types and interfaces. But at the moment, when it comes to getting started, my recommendation is to just use type for everything except for objects. And when you want to type an object, then just use an interface. With that said, thanks for watching, and I'll see you in the next lesson. Now that we know how to define custom types, it's time for us to apply it to an actual Vue app. We'll start by focusing on the data option and seeing how we work with custom types. To get started, be sure to follow along by checking out the branch 06-begin. Let's start by opening up event-details.vue. One of the problems that might not be immediately obvious for those of us who haven't used types before is that currently our editor can't provide much help in terms of what's valid or not. For example, instead of event.title, if someone came in and changed it to event.heading, there's nothing to inform us on whether or not this attribute actually exists. In fact, the only way to really check is to wait until the code runs. And while this might not seem like a huge impediment at first, this can cause a lot of issues and slow down development as the code and data become more complex over time. So how do we get our editor to help us? Well, I want to introduce you to a new VS Code extension called Vue.dx. Vue.dx is a new extension designed to enhance our developer experience with Vue in a lot of different ways. We won't have time to cover everything in this lesson, but just know it's worth taking a closer look at later on. To install Vue.dx, let's go ahead and open up our extensions panel by going to Vue, Extensions. We'll go ahead and search for Vue.dx. After we open it, let's go ahead and install it. Once you've installed it, you'll see that our event details looks a bit different. We see a lot of red squiggly lines. If you don't see this in your editor, you might need to refresh VS Code. And we do that by hitting Command-Shift-P if you're on Mac or Control-Shift-P on Windows. And then we'll run the reload window command. And so now we can see a bunch of errors that Vue.dx is reporting because right now events doesn't have anything defined on it. But don't worry, that's a good thing. Let's go ahead and figure out how to fix these warnings. So the reason we're seeing these warnings is because, as we can see in our component definition, event is actually defined as null. So as far as types are concerned, null will never have any of those properties. So that's why we're seeing those warnings. To fix this, let's go ahead and trace back to see how the event type is structured. When we look at this, we can actually go to the definition of event service, which is where it's actually setting our event property inside of our component. And here we can see the URL where we're actually going to find an example of the data that we're looking for. We go ahead and open this up. We can go ahead and click on the events link. And here we can see how the data should be structured. So let's go ahead and copy one of these examples to help with our TypeScript definition. To get started, let's open back up our file explorer. And let's go ahead and define a new file called types.ts in the source directory in order to centralize where all our types will be defined to also allow other files to import types as needed. And so in here, we'll go ahead and define our event item type. Since it's an object, I'm going to use interface to declare it. So we have interface event item. And here, we'll paste in our example from earlier, and let's start converting it over into types. ID is number, category is string, title is string, and in fact, all of these for this lesson, we're actually going to do string, even though you can certainly go ahead and create custom types to make it more useful, but for the sake of this lesson, we're just going to keep it as string. Now that we've defined it, the one thing we have to do before we move on is make sure that we export the type so that we can import it later on in our component. Now, back in event.details.view, let's go ahead and import our types from the types file that we just created. As you can see, the autocomplete helps let us know that event item does exist and we can import that. At this point, you're probably wondering, well, now that I have the type, how do I actually annotate the data so that it actually reflects what I wanted to do? And based on the information we have right now, we can't do it. But don't worry, I've got a new technique to help you out with this, and that is type assertions. So what is a type assertion? At its core, type assertions allow you to override the inferred type from the editor. In other words, it's a way for you to tell a compiler that you know more about the type than it does. For example, let's say that we had an interface called toDoItem that contains the properties of label string and completed, which is a Boolean. Let's say we have a constant called futureToDoItem, which starts out as an empty object. And so we assign properties such as .label for install Vue.dx extension, for example, or .completed equals true. Believe it or not, TypeScript won't like this, and in fact, it's going to yell at you. And so, by using the as keyword, we're able to override the inferred type that TypeScript pulls, which it thinks originally is an empty object, but we're telling TypeScript, no, it's going to be a toDoItem. I get to introduce you to a brand new keyword, which is the as keyword. And just like that, everything works as we want. Equipped with our new ability, let's go ahead and finish what we started in event.details.view. We'll start by switching over event from null into an empty object. And then we'll add type assertion by using the as keyword and then declaring it as an event item. And once we do that, you'll see that in the template, all of the warnings go away because now everything's been typed and TypeScript can tell what properties actually exist on the event reactive data. And just like that, we've now added custom types to our data property. Now that you know how to add custom types to the data options property, I challenge you to go ahead and add custom types to eventlist.view. You can check out the challenge branch by checking out 06-challenge. So let's review. In this lesson, you've learned about what the Vue.dx extension is and how it helps us with TypeScript. And you've also learned what type assertions are and how the as keyword helps us to do type assertions on things that might not be immediately inferred by TypeScript. In the next lesson, we'll be taking a look at how to add custom types to props. See you there. In the last lesson, we learned how to apply custom types to our data option. So in this lesson, we're going to continue our journey with Vue 3 and TypeScript by learning how to apply custom types to props. If you want to follow along, be sure to check out the branch 07-begin. When we open up event.details.view, you might notice that we have our props currently defined in the array syntax, as you can see here with ID. Using standard Vue prop types, we can define this better by using the object syntax in order to allow other developers to know that ID should be of type number and that it is required. This is great and is useful for a lot of scenarios. But when we look at our event card component, we'll see that we have a prop type applied. And while it's useful to know that the event prop should be of type object, it'd be much more informative if we could actually tell developers how the object is defined. Your first instinct to apply custom types to props would probably start with importing our types that we define in our types file. So we'd import event item. And we might swap out object for event item, but this won't work because event item is a TypeScript type. In other words, it's TypeScript specific, and not something that JavaScript can evaluate. Your next thought might be to use our newly acquired ability to use the as keyword to assert the type, and you'd be close. But this won't work either. The reason this doesn't work is because in Vue, it provides additional functionality like prop validation, which goes beyond the standard type checking that you get in TypeScript. So before we can learn how to properly define custom types in Vue, we need to learn about TypeScript generics. So what is a generic? At this point in time, we've learned how to type basic functions in TypeScript. Here we have our function createList, which takes a parameter of item, which is a type number, and returns an array of numbers. And finally, inside of the function, we go ahead and define a constant that is an array of numbers where we push that new item on and then return the said list. With this function, you get type safety, but it's rather limiting, isn't it? If we were to name this function properly, we'd probably want to call it something like createNumberList. But then this wouldn't be really reusable. So the question is, how do we make this reusable? In TypeScript, this is solved with the concept of generics. At a high level, generics allow you to define a dynamic type that will be used in the function. The way you can tell that generics are being used is when the function name is appended with the greater than and less than symbols. This then allows you to pass in a type rather than a JavaScript value that is typically passed in the parentheses instead. Knowing this, we can now swap out our number type for this new dynamic custom type, which we can pull in when the user invokes our function. And so for the constant number list, we can now pass in the type number, and it'll go ahead and apply it into our createList function. And similarly, if we wanted to create a list of strings, we could then pass in string inside of the brackets, and then the createList function will take care of the rest. Before we move on though, I want you to know that it's actually a convention within the TypeScript community to refer to our generic parameters using single letters, and it typically starts with the letter T. And while personally I prefer to be a little bit more explicit with my variable names, this is a convention that is used in the community, so I don't want you to be thrown off when you see it. But now that we know this, let's go ahead and finish our task. So in Vue 3, when we want to apply custom types to our props, we need the helper method prop_type, which we can import from Vue. Then, all we need to do is now pass event item to prop_type using the brackets, and just like that, we're good to go. Alright, so let's review. In this lesson, we've covered at a high level what TypeScript generics are, how to use the prop_type helper method in Vue 3, and then combine those two things in order to allow us to define custom props in Vue 3. Thanks for watching, and I'll see you in the next lesson. As we begin to wrap up our journey together with the fundamentals of how to use TypeScript with Vue 3, it's time we learn how to apply custom types to computed properties and methods. Let's start with computed properties. So here we have a standard single file component where the language is marked as TypeScript, and we're importing our define component helper method from Vue, as well as our custom event item type that you should recognize from previous lessons. We then go ahead and define our export default object, which contains a data store which has the event key and an empty array as its value. And then we have a computed property which is set to return the first event in that array. Applying what we've learned so far in the course, we can go ahead and type our events inside of our data store using the as keyword and then telling it that it will be an array of event items. But what about computed properties? Well, when it comes to computed properties, the key thing to remember is to focus on typing what is returned. So in this case, our first event property wants to actually return an event item. So all we have to do to type that is to add our colon, an event item, and believe it or not, you've now properly applied a custom type to your computed property. And that's all there is to it. Let's go ahead and address methods with custom types now. Here we have our single file component again, which is a language of TypeScript, and we've imported our helper method from Vue, as well as our custom type that we've already defined. As you can see, we still have our data store, which has an events, which has an array of event item assigned to it. But the difference is that we have this methods option, which contains an add event function, which takes this parameter called new event, in which we go ahead and push that event onto the current events that we're tracking inside of the data store. Now, when it comes to assigning custom types to your methods, there are two key pieces to remember. The first is whether or not you need to type the parameters that are being passed into the method. So here, inside of our add event, we want to actually tell TypeScript that new event should be an event item. And we do that by adding the colon and then the custom type. So in this case, it's event item. And believe it or not, that's all you need to do to type the parameters of your methods. On the other hand, let's go ahead and change the scenario a bit. What if we needed to actually return an actual event from our method? And this time we want to actually type the return. We actually learned how to do this with our computed properties. All we need to do is add the colon and then the custom type that we plan on returning from our method. In this case, it's an event item. And just like that, we've typed what we're returning from our method. And so, just to recap, when we're applying custom types to our methods, we need to check whether or not our parameters need custom types, and finally, whether or not our methods are actually returning a specific type. As long as you do that, you'll be good to go. All right, so let's review. In this lesson, we've learned about how to apply custom types to our computed properties by focusing on what is being returned for the computed property and making sure we define the custom type for the computed property as appropriate. And when it comes to methods, there are two parts that we need to focus on, which is one, whether or not there are parameters that we need to apply custom types to, and finally, if we're returning anything from the method, to make sure and see whether or not we need to apply a custom type to the return value. With that, that's all there is for this lesson. So thanks for watching, and I'll see you in the next lesson. Congratulations! Believe it or not, you're now equipped with the fundamentals you need in order to explore the world of Vue 3 and TypeScript. Of course, for those wondering, this is far from the end of your journey. Like many other things in tech, there are a lot more advanced design patterns and techniques that exist out there that will come with experience and as your apps grow in complexity. And while you'll see a lot of examples out there with TypeScript that seem really complicated and complex, know that you never have to really get that advanced with it. In fact, the fundamentals will carry you a really long way in terms of providing the type support and safety that you're often looking for when it comes to using TypeScript. Like many design patterns in tech, the key thing to understand is what problem you're solving for. After all, it can be really tempting to see these advanced patterns and solutions out in the wild and then try to bring them in anticipation of something that you may have to solve for in the future. But oftentimes this ends up becoming a pre-optimization that, believe it or not, can cause more problems rather than solving problems in the future. And when it comes to TypeScript, it can be a slippery slope in terms of introducing pre-optimization, so be careful when you're starting to do that. And if you're looking for additional resources to explore on your own, be sure to check out the official Vue docs, which now has a dedicated TypeScript section, which will be growing as time goes on. And be sure to check out the official TypeScript docs, which contain all the ins and outs of what you could expect from the language. With that said, while this seems like farewell, there's one more lesson coming up. In this course, we've covered how to use TypeScript with Vue 3's Options API. So in this next lesson, I want to go ahead and show you all the things we learned about in this course and how it can be applied to Vue 3's Composition API. See you in the next lesson.